There are 5 classes of objects we will usually deal with: double, integer, complex, logical, and character. The double data type is the representation of double precision numeric object. By default, all numbers are double in R. Integer is another numeric object representing integer value. In our example, when x is defined as a sequence of 1 and 3, x is a vector with the integer value of 0, 1, 2, and 3. Class function will return the type of the vector x. So here, the class of x will return integer. The integer data type can also be created adding an L to a number. If it's useful if you want to pass some R object to a C or Fortran function that expects an integer value. So it is not generally needed, and we will not worry about this too much here. The complex data type is an object that includes an imaginary number I. Unimaginary numbers are not generally used in statistics. This data type is not very common. The Boolean or logical data type is composed by true, false, and NA values. We can coerce an object to be a different class with as.data type function. For example, if you coerce the object x to logical type, value 0 becomes false, and any non-zero values become true. Character strings are symbols, letters, words, or phrase inside double or single quotation marks. In the example, we coerce the object x to character type using as.character function. The x value are now character with quotation marks. We cannot execute arithmetic operation on the character data. So we cannot really do any math once you actually change it to the character data, which is probably unusual, and you probably aren't going to do it that often. Set of objects can be one of the forms such as a vector, list, matrix, data frame, array, table, or tuple. We'll look at each form one by one, except tuple. For more detailed information, you can check the website listed on the slide. A vector is a collection of elements, and those elements should be all in one class. For example, all elements in a vector should be all numeric or all character values. We can make a vector using C function, small letter c. Here, C function can be used to create a vector, concatenate multiple vectors, or create columns in a data frame. Here we are simply creating some vectors with various types of elements. The vector x is created as a vector of character string elements of small character of alphabet A, B, C, D, E, and A. The vector y is created with 5 numeric elements. The vector z is created as the logical elements with true and false. The square bracket are used for indexing into a vector, matrix, array, list, or data frame. X square bracket 1 extracts the first element of the vector x, which in our example is a character A. X square bracket 1 colon 3 extracts from the first to the third elements of the vector x, here A, B, and C. Let's try a couple of practice problems before we move on to the next slide. First, create the new vector v1 with the elements of 1, 2, 3, 4, and 5. Then add y, the previously used vector y, and our new vector v1. What happens if you add two vectors? Try to add x, which with character elements, and y with numeric elements. What happened? You should have an error here since you cannot add the character and the numbers. How about y plus z? It will return a number treating true as 1 and false as 0. When the column length is different like y and z, once the fourth elements were used, it will go back to the first element of the short vector z and will add 8 and true, which is 0. A list is very similar to a vector, but we can use different type of elements in a list. We can create a list variable using list function. In the example, the list X created a list of 3 components of A, B, C with numeric, logical, and character elements. X will return all the elements of the list X, but it is organized the way that there are 3 different components with different values. X $A will return the elements 1, 2, and 3. X $B will return the elements true, false, and true. Once again, if we add these 2 elements, it will add each element treating true as 1 and false as 0. A matrix is a combination of multiple vectors. It takes 2 dimensions, row and column, and each column must have the same type of the elements and length. This means the elements of matrix should be all either numeric or all character or all logical, and the number of rows should be the same for all columns. We can create a matrix using matrix function. In our example, we are creating a matrix Y with elements A, B, C, 1, 2, 3, 4, 5, 6, with the number of rows to be 3 and the number of columns to be 2. By default, the number actually goes column-wise by default. And if you want to change that, there's a by low function option that you can use inside of matrix function. We can also create a matrix using existing vectors. For example, the list X from the previous slide, cbind function will also create a 3x2 matrix with 2 column vector, $A and $B. A data frame is the most common real data set form. It is similar to matrix, but we can have different type of elements in each column of data frame. And also you can have the names of each column like a list variable. Suppose we have 4 different column vectors, X, Y, Z, and W, with numeric or character elements. Using data.frame function, we can create a data frame with all vector information combined. Notice that here, all our column vectors are not exactly same types. We have numeric types and we also have character types. But data frame, you can actually have different types of columns in one data frame. When we're dealing with 3 or more dimensions, we can use array type. In an example, we created array Z with element 1 to 12. The dimension of Z is 2 arrays with 3 columns and 2 rows. A vector is very similar to a vector, but with numeric codes for each character results. It sometimes is called a categorical variable. In our example, Z is a vector with character elements. If you change the type of Z to vector, it will return the same information, but this time it is not a character anymore, but it is considered as a category with multiple levels. An ordered factor assigns an order to the categories. In the example, as that ordered function returns the factor with the alphabetical order. We will see this form, the level goes from the level goes from freshman, junior, senior, and sophomore order. We can also specify the order of the level. In the second example, the factor function, we can define order that's true and specify the order of the levels as we want it. Later, this function might be helpful when we want to organize information in a particular order. Now you can see the level has the order of freshman, sophomore, junior, and senior, more regular order, not alphabetical order. The class of an object can be identified using the function class. The class of the previously used object can be also found in the Environment tab in the upper right corner of RStudio. From the previous example, the class of the vector W is numeric, and the class of Z is character. The class of Z underline ordered contains 2 elements, ordered and vector, and the class of things 1 on slide 17 is data frame. The real data often include missing values. In R, NA is the most common representation of the missing value. From the slide example, we see the variable A is a vector with numbers and NA and false. NA and logical element false follows the object class. So here it will actually treat like a numeric. Note that false is considered as 0 here. is.na function is often very useful especially when we deal with the data with missing values. The function will return true or false if it is missing value or not element-wise.